All right, so in this module, we're going to go through an example of how we do this labeling of phase fields, only knowing some of the labels. All right, so we're going to go through the hafnium-vanadium phase diagram, which again only shows single phases, and I want you to label all of the unlabeled phase fields of this diagram. So see if you can go through and label the rest of them. And same thing as always, go over the quiz and then just see if you can answer that and then come back and we'll work through it together. All right, so hopefully you've had a chance to look through this, and now we're going to go and label these. So let's go ahead and see if we can label these together. And I'm going to work through this with a pen here, and hopefully this works out. So just like I said, we have single phase fields labeled, and we know that the only place that we can have a single phase next to a single phase is at a congruent like this, or any pure phases like here and here, and also here. Otherwise, there has to be two phase fields separating. So if we have this region, we have a single phase around it, a single phase around it. So this has to be a mixture of those two single phases. So liquid plus vanadium. Same thing here. This is referring to the small region here. So this is unlabeled. So this is going to be hafnium. This might take me a bit with a pen here, but this is hafnium vanadium 2 plus the vanadium phase. And then if we keep going, you see this small phase is unlabeled as well. So I'll probably just have to do an arrow here, right? And everything around that is this hafnium and then the liquid, right? So we have and then plus liquid. All right. Same thing here. We have hafnium vanadium 2 and a liquid. So these actually are going to be labeled the same way, but I'll rewrite them just to be clear. I apologize for this, but hafnium vanadium 2 plus liquid. This region, we can do this one next. It doesn't really matter which ones you do, so just pick it however you want. This is going to be alpha plus hafnium vanadium 2. All right. And again, keep in mind that the arrows tend to indicate when it's hard to label. So, again, this very small sliver is actually alpha. So it's not labeling this region here. And then let me finish doing all of these hafnium vanadium 2. So in this region, we've got this phase around it, and also this one over here, which is the single phase beta. So we're going to do beta plus, and I'm not going to write beta hafnium, so just take my word for it. I'm trying to minimize how much I use this pen for. All right. And then we have this region up here, which is beta on the left plus liquid on the right. All right, let's see where I'm at now. I've got this one, this tiny one, this one, this one, this one. There's also this, right? Because it have alpha here on the left and then beta on the right. So this is, oops, might have to do that one again. Alpha plus beta. All right, so I think that's all of them. And again, just the most difficult thing here is that some of these very narrow regions, like particularly this one, it's hard to read, but when it's pointing to that, it's most likely talking about a line or a very limited solubility where you can't quite label it. So that's why we have the arrows up here as well, because it's very small and difficult to label. So you often have to resort to labeling it with arrows. So that's how we do it. Again, it's very simple, but I just wanted to show you that because there are a lot of reported phase diagrams that do not label all of these regions. And something else that you should be able to take away from this is that usually single phase regions are labeled. However, if it's if some two-phase regions are labeled instead, you should be able to go through the same idea with that, right? If this is labeled as liquid plus vanadium, you would know that this region is a liquid and this is vanadium. So you should be able to go the opposite way as well with this type of exercise.